Hey everyone, welcome back, and today let's solve Leetcode problem 670 titled Maximum Swap. So we're given an integer num and we can swap two digits at most once to get the maximum valued number. We need to simply return the maximum valued number that we could potentially form or get. Right, so in example 1 we have the integer num to be 2736 and we hence output 7236 because we can swap the number 2 with the number 7 and get the maximum valued number from 2736 to 7236 with one swap of two elements or one pair in this input integer num. Okay. In example 2, we have the input integer num to be 9973, and we hence output the same input because we can't have any swaps to potentially make this number a larger valued number, as 9973 is the maximum valued number we can get, and regardless of which two elements or numbers we switch in this input integer num, we can't actually form a value that's larger than 9973, which is in this case our original input, and that's why our output is going to be the same value because we don't have any swaps potentially needed to make a value to make a larger valued number. Okay, so with that problem statement out of the way and those examples covered, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so the way we're going to solve this is we're going to basically first convert the number to a list of digits, right? And this is going to help us swap digits easily since strings are actually immutable and we'd rather have a list of all the different digits in our input integer num. Then we actually have to record the last occurrence of each digit from 0 to 9 because this would help us quickly find the right digit to actually swap. Then we actually have to iterate over the digits from left to right, and for each digit we have to try to find a larger digit to the right that can actually be swapped. And if a swap is actually possible, we need to of course swap the two digits and return the new maximum number. But of course, if no beneficial swap can actually be made, we simply return the original number as we saw in test case or example 2. Right? So of course we're going to use a list to actually hold the individual digits. We're also going to use a dictionary to store the last occurrence of each digit, and then we'll have a nested loop to traverse the digits and identify possible swaps between two elements or a pair of elements in the input integer num, okay, which we will eventually store the digits of in the digits list. Okay, so like I was talking about before, I'll have digits to be a list of the string of nums, or num rather, right? Where again, here num is going to be the input integer, and first we have to actually convert it to a string in this str or string of num method in Python. Then we actually have to use the list method, which breaks the string into a list of characters, each representing a digit, right? And the reason why we use a list is because integers cannot be split directly into individual digits, and so we'd have to actually use this str method first and then convert it from there to a list, right? So I'll just comment this out. For example, if num, let's just say it was 2736, taking the first example, or example 1 in this problem statement, then we'd see that digits would be a list of 2, I think that's right, 7, 3, and 6. Okay? As you guys can see, it's basically every single individual digit mapped as a string in the digits list. Okay? Okay. And once we actually do that, now we want to initialize our hash map to store and map the last occurrence or index of each digit to its corresponding digit, right? So we'll say last is equal to a dictionary or a hash map, and in Python this is incredibly easy using dictionary comprehension, where we say integer value of d is mapped with its index I for I and d in the enumerate of the digits list, right? Or again, we're basically initializing this dictionary called last to hence store the last occurrence of each digit. And the enumerate of digits returns or saves both the index and the value of each character in the digits list. And the int of d converts each character back to an integer from a string before actually storing it in the dictionary, right? So for example, I'll comment this out as well once again. If digits, as we saw before, was the same example 2736, then the last hash map would basically map every single element with its last corresponding indice. So 2 would be mapped with 0, 7 would be mapped with 1, 3 would be mapped with 2, and 6 would be mapped with 3. Okay, that's how this last hash map would look in that specific test case or example, right? And the reason why this hash map is actually needed is because this quickly helps us find where each digit last appears, which again is important to know if we can actually swap it with a larger digit later on in future iterations in the rightmost of the array. Okay. So once we actually do that, now we'll actually regularly enumerate through the input integer num, or in this case, list of digits. So we'll say for I and D in the enumerate of digits. Keep in mind, it's just going to have a list of all the different strings of digits in the input integer num, okay? And we'll have a nested loop, right? So for j, or in this case, I'll say for bigger, so it's a little bit readable, in the range of 9 till integer value of d, decrementing by 1 each time, right? So again, in Python, what this does is we're basically trying to find a larger digit than the current one, d, by iterating from 9 down until the current digit, decrementing by 1 or minusing by 1 from the current value in each future iteration, right? Where the range of 9 till the integer value of d minus 1 each iteration creates a sequence of numbers starting from 9 down to just above the current digit, decrementing by 1 each iteration. So for example, if d was equal to the string of 2, then the range would be the list of 9, 8, 7, 6, 5, 4, 3, but not including 2. It'd be going down to 2, but it won't include 2 in that corresponding range. Okay? And the reason why we use this range is because we want to find the largest possible digit to swap and maximize the result. Okay? And once we actually do that, now we actually have to check if the last hash map.get at bigger with the value -1, if it's actually greater than I, right? And again, this if condition basically checks if this digit or if this larger digit exists to the right of the current digit by comparing its position to last at bigger to the current index I. If that's true, it means there's a larger digit available for swapping that comes after the current digit. And so if that's the case, we want to set digits at I and digits at last at bigger to be, okay, this should be double G, to be equal to, basically setting them equal to the reverse of each other, so digits at last at bigger and digits at I. Okay? So basically, this is the condition where we swap the digits. We swap the current digit at index I with the larger digit found at last at bigger. So for example, if we swap 2 at index 0 with 7 at index 1, the digits would then become 7, 2, 3, 6. And after the swap, now we actually have to return the string.join to actually concatenate it back to a string, the digits, right? But of course, we also have to convert this back into an integer because they want the return type to be an integer rather than a simple string, okay? And again, this string.join basically concatenates or combines the list back into a string and converts those string to an integer using the int keyword. And the reason why we return immediately is because we're allowed only one swap to actually maximize the number. So we have to return the digits as soon as we make that swap. And if we don't actually find a larger, more maximized value number, then we can return num outside of this for loop, because if, of course, no beneficial swap can actually be found in any of these nested for loops, then the loop would complete without swapping, and we can hence return the original number like we saw in example 2, or test case 2, if you will, right? So unless I made any syntax errors here, this should be accepted and they should be submitted on Leetcode. And as you can see, this is just about as efficient as you can get. So to better explain what the code does overall, basically, we have to find, again, the maximum possible number by swapping at most one pair or two elements of digits in the input number. And what we do is we first check each digit from left to right and look for a larger digit to swap. And if a swap is actually found, we can swap the two digits and immediately return the new number. But if we don't do that for any iteration in the nested for loops, then we can basically return the original input, saying that no swap can actually improve or maximize the valued number after the swap. Right, so for the time complexity, the first part, basically creating the last dictionary, takes big O of n time, or n is of course the number of digits, and the nested loops also take big O of n in the worst case, making the overall time complexity big O of n. Technically it's big O of 2 times n, but again, coefficients don't really matter in time and space complexity, so this would basically be simplified to big O of n, or a linear time complexity solution. For the space complexity, this is going to be a big O of 1 space for the dictionary, because we need to actually use a dictionary to store the last occurrence of each digit, where that would take big O of 1 space, since there are only 10 possible digits from 0 to 9, but the list of digits would take big O of n space, and so the overall space complexity is going to be also linear time, or big O of n. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel, and without further ado, I will see you guys in the next video. Bye bye.